This is our Precalculus 4 6 weeks common assessment 2017. We have 19 problems here total. We'll go over all these. And the measure of angle C is 225 degrees. What is the measure of angle C in radians? So what you could do here is you could convert the answer choices into degrees, or convert this 225 degrees into radians. And really, if you have a basic understanding of the unit circle, right, something like this, you'll know that 225 degrees would be over here, halfway between 180 degrees and 270 degrees. And the correct answer is going to be 5 pi over 4. Pi is equal to 180 degrees, and 5 pi over 4 would be down here 225 degrees. And if you lack this level of understanding, you can take this 225 degrees and convert it into radians by multiplying by pi over 180. And that's going to convert into radians, and what you're going to have is 225 over 180 simplifies to 5/4, so you can have 5/4 pi. So anyway, let's go ahead to problem 2. Theta is the angle of inclination in the drawing shown below. Which angle has the closest measured angle theta? And basic understanding is your theta is going to be this symbol right here. So you're talking about this angle between the ground level and line of sight up toward the top of the building. So basically, what you have for this triangle outlined here is your 700 feet high of the building is going to be your opposite side of our triangle, and this 500 feet below is going to be your adjacent side. And the trigonometric ratios involving opposite and adjacent would be tangent. So tangent theta is going to be 700, which are opposite, over 500, which is our adjacent side. And one thing you could do is you take these individual answer choices and just calculate the tangent of each of these and see which one is closest to 700 or 500. Or you can take the inverse tangent, because undoing this tangent would be the inverse tangent, and so taking the left side, the inverse tangent of tangent is theta, and on the right side you have inverse tangent of 700 over 500, which is just like 7/5, 7/5. So we go to calculator, and we can go here to, now one thing in our calculator is up here in the upper right corner of the view screen says DEG, indicating that our calculator is in degrees mode. It's a recent update. Anyway, we go to tangent, inverse tangent, and we're going to take 7 over 5, and for that we get about 54.5 degrees. So let's go look at our answer choices. So our closest to that is going to be answer choice B. Okay, 3. The Chrysler Building in New York City was the tallest building in the world at the time it was built. It cast shadow approximately 130 feet long on the street when the sun's rays form an 82.9 degree angle with the earth. How tall is the building? Well, really, you're kind of looking at a drawing similar to that of problem 2. But here we have a building. Okay, this is our Chrysler building. And we have the sun shining down right here, casting a shadow And that shadow will be like this, comes straight down to the ground. And this angle here is 82.9 degrees. And a shadow approximately 130 feet long. So here's the shadow right over here along the ground. That shadow is 130 feet in length. And then we want to know the height of the building. So here's the height. Well, again, as in problem 2, we have the tangent of theta equals our opposite over our adjacent, which in this case, the tangent of 82.9 degrees is equal to our height, which is our opposite side. Okay, height is our opposite, and 130 feet is our adjacent. So height over 130 feet. And if we cross multiply 130 feet, height is equal to 130 times the tangent of 82.9 degrees. You could also, from this equation here, use numerical solve. You could use cotangent, which would be 130 over h. Anyway, so we're seeing we're still in degrees, 130 times the tangent of 82.9 degrees. And we get 1,044, rounded to the nearest foot. Okay, well, around the nearest foot would be 1,044, but this A is definitely going to be our closest choice by quite a margin. Next, problem 4. Car goes up a slant length of 1,000 feet is shown. For that distance, the car's elevation increased by 60 feet. What was the car's angle of inclination? Well, angle of inclination is going to be how steep that angle is, the direction of that angle from the ground level. So that's going to be this one I've just drawn here in blue. And so the 60 feet here is going to be our opposite side. And our 100 feet here, our slant height, is going to be our hypotenuse. And so what you're looking for here is the opposite over hypotenuse. Well, sine theta equals opposite over hypotenuse. And what that is going to be is sine of theta, which we don't know. It's going to be our opposite side, which is 60, over our hypotenuse, which is 1,000. And that's going to simplify to 6 over 100 if we cross out the zeros. But again, like we did in problem 2, to isolate that theta, if we take the inverse sine of both sides of this equation, we get theta is equal to inverse sine of 6 over 100. Okay, where does 6 over 100 come from? Well, it's simplifications. Cross out these two zeros. So, we have theta is equal to, we go to inverse sine of 6 over 100. That'd be 0.06. We'll get 3.44. So let's go look at that. So 3.44 degrees. And again, that's going to be closest to answer choice B. Next, 5. Guide wire from the top vertical transmission tower at WJ BC forms a 75-degree angle with the ground at a 55-foot distance from the base of the tower. About how tall is the tower? Well, again, we want to find this height. We're going back to problem 4 pretty much, with the drawing this time. And that's going to be our opposite of this angle 75, right? Opposite 75 is our H. And this 55 feet below here is our adjacent. So we have tangent of 55 degrees is equal to H over 55 feet. Except I got that wrong, didn't I? It's tangent of 75 degrees. Okay, that looks better. So cross multiplying, H is equal to 55 times the tangent of 75 degrees. And going to our calculator, we'll see we're in degrees to 55 times tangent of 75 degrees. We get round the nearest foot 205 feet. So let's go over here. And that's going to be answer choice C. Next, problem 6. The arc of circle with radius of 12 inches has a length 23 inches. To the nearest degree, what is the measurement angle that describes the arc of the circle? Well, the arc length formula is S is R times theta, and this is going to be your version in radians and 4 degrees. To convert this angle into radians, it's going to be S equals R theta, and to convert this theta into radians, we're going to multiply this by pi over 180. And just filling in the equation here, our arc length is 23 inches, so 23 inches will go here, 12 inches is our radius, will go right here, and we don't know what this theta is, but we can try to find out. So we'll say 23 is equal to 12 theta times pi over 180. If you have numerical solve in your calculator, which is a feature of the Inspire CX calculator, you can go right from here, or you can divide by 12 both sides. That cancels out. So we have 23 twelfths equals theta times pi over 180. And we can multiply both sides by the reciprocal of pi over 180, which is going to be 180 over pi. And then this other side on the left, we can multiply that by 180 over pi. And so we have cancellations here. So theta equals 23 twelfths times 180 over pi. I'm going to do that first. 23 twelfths. Oops. Here we go. 23 twelfths times 180 over pi. There's 180. Down here is our pi symbol. It's that H. Center. This. So we get about nearly 110 degrees. And if we just did n solve from our original situation, I'm going to put that original equation in here. It's going to be, I'll go to menu, algebra, numerical solve. So 23 which is our arc length, equals 12, which is our radius, times theta, which we don't know, times, we're going to take pi over 180. So that's our equation here. And we're going to put comma x as enter. We also get 109.8 degrees. Which is approximately 110 degrees, which is close to answer choice C. Next, for a right triangle shown below, what is secant theta? Well, secant, it's basically understanding what our trigonometric ratios are. Secant theta is going to be our hypotenuse over our adjacent, and it's the reciprocal of cosine. Cosine is theta is going to be adjacent over hypotenuse. And so our hypotenuse is going to be this guy right here, 20, and our adjacent side is going to be 5. So secant theta is going to be 20 over 5. And 25 by 5 simplifies to 4. So our correct answer for number 7 is D. Next, 8. Solve for the unknown in the nearest tenth. Here we have angle, and we have the opposite side of that angle, 35 degrees, is 29. And this side y is going to be our hypotenuse. So what we have is we have a couple choices. We can take sine of 35 degrees is equal to our opposite, which is 29, over our hypotenuse, which is y, solve for y, or we can use our cosecant 35 degrees, which is going to be the reciprocal of sine, which is going to be our hypotenuse, y, over our opposite, which is 29. And so therefore, cross multiplying, y is going to be equal to 29 times the cosecant of 35 degrees. So we go to our calculator, 29 times cosecant 35 degrees, which we're going to get 50.56. So degrees. Actually, not degrees, it's length, right? It'll be feet or whatever. That's going to be close to answer choice D. Now, one thing you can do, if you don't have a cosecant key in your calculator, you can go ahead, sine is your reciprocal, so we could make this, instead of 29 times cosecant 35 degrees, we can tell it's 29 over sine of 35 degrees, which will get the same thing. And again, you could, if you had numerical solve in your calculator, you can use either of these two equations here to get that. Should be quite an easy problem. Most of these should be pretty easy. For an angle that measures 5 pi over 4 radians, the standard position, what is the value of reference angle in degrees? Well, this comes back to, does it not, maybe the first problem we have in this test. If you take 5 pi over 4, and we convert this to degrees, we can multiply this by 180 over pi, and pi over pi cancel. So we have 5 times 180 over 4. Well, 180 over 4 is 45 degrees, so we have 5 times 45 degrees, which is 225 degrees. And so we have that's really a bad looking circle over here. Okay, so our 225 degrees is this thing right here. Okay, and we get our reference angle by dropping straight to the x-axis. So it's going to be this, our reference angle is going to be, I'll put a little alpha right in here. And to get that numerically, we're going to take 225 degrees minus 180 degrees. See, this is going to be 45 degree angles. And yes, your reference angle is going to be between 0 and 45, which would be eliminate D automatically. So C is our correct answer for problem 9. And a circle has a radius of 2 miles. What is the length of an arc that has a central angle measure of 2 pi radians? Well, again, we have S equals R theta. And we say we have 2 pi radians, so we can go ahead and just put in our angle right there. And our radius of 2 miles will go right here. Okay, so it should be pretty. S equals 2 times 2 pi, which equals 4 pi. And it may not be totally apparent what that is, so we can just go to our calculator and put in 4 times pi, 12.6, round to the nearest tenth. Miles, okay, answer choice A. Next, 11. What is an expression for angle theta? Well, here we have theta right here. Over here, 29 is our opposite. And down here, 36 is our adjacent. So we would have our choices. So theta is going to be equal to inverse tangent of 29 over 36, or we can write this as theta equals inverse cotangent of 36 over 29. Okay, so it's going to be answer choice A. Yeah, this one right here, this one here is not equal to the angle, but is equal to tangent of angle. So that's what makes answer choice B incorrect. And this one here would be 36 over 29 would be cotangent theta, but not theta. Okay, theta would be the inverse. So I think some people were pretty suckered in by answer choice B. 12. The measure of angle M is 37.25 degrees. What is the measure of angle M in DMS? Well, DMS stands for degrees, minutes, seconds. So what we're going to have is 37 degrees plus, and to convert this 0.25 into minutes, we're going to multiply that by 60. And that's going to be that many minutes. So we get 37 degrees, and then 0.25 times 60 is 15 minutes. So our correct answer for problem 12 is B. Pretty easy. Next, 13. John stands atop a cliff 150 feet above sea level. He looks upon a small boat quite a ways off and measures the angle of declination to the boat to be 3.5 degrees. What's the horizontal distance from John to the boat? Drawing on scale. Well, here we have this distance here. Okay, we are trying to find this distance here, horizontal distance. And in the language of trigonometry, from this angle right here, or we can call it this angle here, right? Same thing. And our height is 150, our distance is going to be our adjacent side, and 150 feet is going to be our opposite side. Well, what involves opposite and adjacent? Well, tangent of 3.5 degrees is going to be equal to our opposite, which is 150 feet, over our adjacent, which is our distance. Or we can also say cotangent of 3.5 degrees is equal to our distance over our opposite, which is 150 feet. So we can cross multiply our distance. It's going to be equal to 150 feet times cotangent of 3.5 degrees. So going to our calculator, we have 150 times cotangent of 3.5 degrees. And for that we get 2,452 feet. Okay. And one thing you can do, that's your choice, you can take this angle here, which is going to be complementary. It's going to be 86.5 degrees. If you don't have a cotangent button, you can write this as tangent of 86.5 degrees is equal to our distance over 150. And solve this way. Get the same thing. Okay, next, problem 14. An owl is perched atop a 40-foot tree. There's a mouse at the inclination of the owl 40 degrees. And to get safety from the predator owl, the mouse needs to reach a hold in its angle inclination of 35 degrees to the owl. It's the nearest 10th foot. How far must the mouse go to get to the safety of the hole? So basically, we're looking at two triangles. We're looking at this one here. I'm sketching in blue. And this one, now that I'm going to be sketching in red. And so for the red one here, we're going to have cotangent, this distance here. Okay, that's what we're looking for. I'll call this y. So we'll say cotangent of 35 degrees is equal to y over our height of 40 degrees. And for the other triangle, we have cotangent of 40 degrees is equal to x. We'll call this distance here x. Over 40. And so we'll just, and so we have 40, we have y, it's equal to 40 cotangent 35 degrees. And we have down here, x is equal to 40 cotangent 40 degrees. So we can just go to our calculator and we can say 40 times cotangent 35 degrees, subtract out 40 times cotangent 40 degrees. And we get about 9.5 feet. So So y minus x equals about 9.5 feet. And our answer choice for that is A. Next, 15. Law of sines we used to find the side length of an angle of a non-right triangle. According to the equation being used to solve for side C, what is the length of side C? And there's 10 centimeter. Here, we haven't really gone over the law of sines, but I just presented this as just an equation. We can just solve this equation right here. We would have it. We can cross multiply the sine 41 degrees, or we can just use numerical solve. I guess I'll try to do that. So we go to menu, algebra, numerical solve. Okay. We have x over sine 41 degrees. And that's going to be equal to, let's see what it is here, don't remember it, 72.5 over sine 94 degrees. So 2.5 over sine 94 degrees. And come here, press comma X, we should get 47.7. Okay, so 47.7, C, 47.7, which is answer choice A. Next, 16. Which pair of angles measures below in the answer choice represents a pair of coterminal angles? Basically, you're looking for angles that are 368 degrees or 2 pi radians apart. And so if you're looking for the difference of these, so if we take 90 minus negative 90, we're going to get 180 degrees. And these would not be coterminal angles. And if we just looked at answer choice A, we'd be looking at this angle of 90 degrees here, okay, at this point, and this angle of negative 90 degrees. Do these two angles end in the same place? No, they don't. And then between 450 and 45, well, it's going to be 450 minus 45. We're going to get, what is it, 405 degrees. Not coterminal. This one right here, 270. Well, again, back to our drawing, 270 would be like this, right? That's 270 degrees. That's 270 degrees. And then we have this negative 90. Say they would end in the same place. And also 270 minus negative 90 is going to be equal to 360. So these two angles are 360 degrees apart, therefore coterminal with each other. Next, for your response section, arc of circle has central angle of 100 degrees. What is the length of arc? The diameter of the circle is 14 inches in length. Give your answer to the nearest tenth of an inch. Again, we have S equals R theta. And since we're in degrees, we need to convert into radians. We're going to multiply this by pi over 180 if we have degrees. So we're going to take this 100 degrees right here, plunk that in here. We're going to take this 14. Well, the problem is 14 is not the radius, but 14 divided by 2 is the radius. So R equals 14 over 2, which equals 7. So our 7 is going to go right here. Okay? So basically, if we just take S is going to be equal to 7 times 100 times pi over 180. So go to our calculator. We have 7 times 100 times pi over 180. And we're going to get 12.22 around the nearest hundredth. And it says to the nearest tenth. Well, that's going to be 12.2. So we can just put in 12.2, and here is 0.2. Should have been quite an easy problem. Only a little tweak in there is that degrees and also this diameter. Next, 18. An angle in standard position measures 330 degrees. What is the measure of its reference angle in degrees? Well, again, what we have is we have a standard circle here. We have an angle of 330 degrees. That's going to be right about like this. And it's going to be your angle of 330 degrees. Well, how do you find out what the reference angle is? Drops straight up to the x-axis. So this alpha here is going to be our reference angle. So we have 330 degrees here. And how do we find that? Well, if we take 360 degrees minus 330, that's going to give us our reference angle of 30 degrees. So we can just mark in 30. Again, it's positive, so we don't have to put a plus here. So we just put in 30. And you can put 30 any place in these boxes. Some people put it at the very end still. Grid-wise gives you a correct answer. Next, our last problem, 19. Well, shadow length of church measures 120 feet. So we're talking about this distance here being 120 feet. Okay, that's our 120 feet of shadow length. What is the height of the church? So here's our height. Okay, what are we looking at? We're looking at tangent 55 degrees equals our height over, which is our opposite side, over our adjacent, which is 120. So h is going to be equal to 120 times tangent 55 degrees. (120) times tangent 55 degrees, and we get 171.378. I'm just going to write that down. Okay. Here's where some people missed it. It says to the nearest tenth of a foot. What is the nearest tenth of a foot? Well, it's going to be 171 point, the next one after that. So this one's going to round to 4. So if you put down 171.3, which I saw some people do, or even 171, those answers would be wrong. If you put it out to more decimal places like 0.378, you get it right in the automatic rounding would bail you out. So 171.4. So here's 171.4. Should not have been hard at all. Again, most people, even those who got it wrong, did the mathematics correct, but the rounding error might have messed you up. So, anyway, that's it. I don't think it was that hard of a test. Good luck in your future studies, and thanks for viewing.